Hello students, how are you? My name is Hrithik Jaiswal and I'm going to teach you today how you can solve the question which is related to the relation. So this is very important question. It often come in the exam and the question is show that relation R on the set A where x belongs to the integer and x in between actually is 0 to 12. Okay, given by the relation R equal to AB such that mod of A minus B is actually the multiple of 4, and you have to show that it is an equivalent relation. Okay, and one more thing, you have to prove that find the set of all elements related to the one, actually that is the equivalent. We can also write it as this in the bracket. Okay, so this is actually the question. So let's solve it. So what is given here actually, A equal to A has restrictions and the relation is from A to A. Okay, and it is actually given that what is given, R equal to A to B, mod of A minus B is a multiple of 4. You have to keep it in the mind, and let's solve it. Okay, so how would you solve this question? So first, if you want to prove the equivalent relation, so we have the reflexive first, the reflexive, second the transitive, and third is second the reflexive, sorry, first reflexive, second symmetry, and third transitive. So if you want to prove for the reflexive, you need to approach this question like this: for any A belongs to A, and A, you know that A belongs to where? In between 0 to 12, you know this. So you have to just first keep this in mind. I can write here first what is A. A is actually, you need to keep in mind that x belongs to Z, such that x in between 0 to 12. And what about R? R is actually AB, such that A minus B is multiple of 4. All right, now we need to prove the reflexive. So how would you approach this question? So we'd write here, for any A belongs to A, we have what the meaning of this? R, you know that mod of here, mod of A minus A, what would it be? It would be 0. And what can you say about this? Which is a multiple of 4. All right, so in this case you can say that A belongs to R for all A belongs to actually A. So what can I say about this? So A is, so R is reflexive. All right, you need, if you want to prove reflexive relationship, then this is the order actually. So AA belongs to the ordered pair, AA belongs to R. So this is the relation actually. Now second is symmetry. Okay, all right, symmetry. If you need to prove symmetry, so how would you approach this question? So you have to assume two things. Let AB belongs to R, okay, and you need to prove what? BA also belongs to R. If you're able to prove BA belongs to R, then your question will be, that means the symmetry will be over. So how would you then, since you know that, since you have assumed what? AB belongs to R, so what the meaning of this? This means that mod of A minus B is what? Is a multiple of 4? Is a multiple of 4. What the meaning of this? Now if it is a multiple of 4, then what is the meaning of this? So if a minus b is a multiple of 4, you can also write here b minus a is also multiple of 4. Alright. In this way you can say that BA belongs to R. If BA belongs to R, so R is symmetry. Now R is symmetry. Okay, since you know that a minus c mod a minus b is a multiple of 4, so you can assume it as 4 lambda. Okay, mod a minus b 4 lambda, or and then mod a minus b is nothing but mod b minus a. Okay, so it's also, it's not equal, you cannot assume it, but since it is mod a minus b is a multiple of 4, you will also get the value of mod b minus a will also be multiple of 4. So in this case B belongs to R, and so reflexive symmetry relation is proved. Now you need to prove whether it is transitive or not. So in order to prove this transitive, you need to prove that you first assume that let AB belongs to R and BC belongs to R, and you have to prove that AC is also belongs to R. So what is AB? So AB is actually mod A minus B, which is a multiple of 4, and again B minus BC. What is BC? Is B minus C is multiple of 4. So you can assume it as A minus B equal to 4 lambda 1. Okay, since it is a multiple of 4, B minus C 4 lambda 2, where lambda 1 and lambda 2 belongs to natural number. Okay, now since you know that if A minus B is 4 lambda, so what about A minus B? Without modulus it would be plus minus 4 lambda 1, and what about B minus C only? It would be plus minus 4 lambda 2. When you solve this, because you need to find the value of A minus C, how would you approach this? You need to that means manipulate this, like manipulate this by introducing minus B and plus B here, like this. This is A minus B and B minus C. What is value of A minus B? It is plus minus lambda 1. What is B minus C? Value of B minus C is plus minus lambda 2, 4 lambda 2. Sorry, it is 4 and 4 lambda 2. If you take 4 common, it would be plus minus lambda 1 plus minus lambda 2. Okay, then you can say that here mod of A minus C is also equal to 4 plus minus, okay, 4 not multiple of 4. Okay, so this means AC belongs to R. Thus, how can you solve this? You have assumed AB belongs to R and BC belongs to R, and you have proved that AC is also belongs to R. So what is this? Your now the transitive part is over. So it is actually, you have proved, since you have proved what reflexive symmetry and transitive in all the cases. So by this way you are able to prove that it is actually an equivalent relation. R is an equivalent relation. Now you need to prove that the set of all element which is related to the related to the 1. So how would you approach this question? So assume let x be an element of, let x be an element of A such that x comma 1, because you need to find the set of all elements related to 1. So here x comma 1 belongs to R. What the meaning of this? According to the question, it is actually mod x minus 1 is multiple of 4. What is x minus 1? The value of x minus 1 will be actually 0, 4, 8 and 12. It would be more, but because there is a range, the given range, so will be in that. So it would be, if you say x minus 1, it would also be 0, 4, 8 and 12. Then x is nothing but